So next up, we have 4 postdocs from the Alan Turing Institute, Hadrien, Salat, Zanchetta, Fernando, Benitez, and Roman. And they're going to talk about extending the model which Gavin Shaddick introduced to us in one of the sessions this morning. So over to you guys.
Thank you all for introducing our talk. So as you just said, we are going to talk about extending the DIME model to the national scale. So in case you couldn't follow the talk this morning, the objective is to introduce an SEIR type model into a pre-existing model of human social behavior and context with appropriate statistics to change its labels. So that results in the DIME model that uses as pre-existing model of social behavior the Spencer population microsimulation workflow, which was developed at the University of Leeds, and the quant transport simulation workflow, which was developed at CASA UCL. So this model allows to study the spread of COVID in the UK and assess the quality of policies. There's a preprint by Fiona Spooner describing in detail the first stage of developing this model. So it's not yet available, but it should be soon. So the model was developed by various universities and not universities, not all listed here, the same as this morning. It's not really much change. However, the initial model was only calibrated for Devon. We therefore needed to acquire the remaining data and make the code more flexible to accommodate a wider range of areas and support a wider spectrum of applications. We also took the opportunity to refine some aspects of the modeling. In the next slides, we will present the current version of the model that will offer a short recorded demonstration and discuss the future of the model. So the model can currently accept as input any list of MSOAs within England. In case you don't know, MSOA is a geography containing about 8,000 people. There is an assumption that this list would be coherent, although there are no technical limitations to choosing something entirely random. We would love to have the model running for Wales and Scotland. Unfortunately, there are discrepancies in the data structures, so we are limited to England, at least for now. So a start date needs to be specified. This can be, again, anything, although we do provide some help for seeding and a way to implement a lockdown model. So in order for that to work, the date would have to be after the 5th of March, 2020. So one thing is it's necessary to provide the number of cases at, the number of active cases at day 0. We do provide some help to achieve that, but it's based on national data. So for a specific study area, it might be worth searching for more specific data. The point of that is also it allows to have more flexibility and try what-if scenarios where the number of cases is freely chosen. These are the two main data sets that make the model work. So Spencer creates a synthetic population of individuals in England. It's based on the 2011 census, and so it's projected to 2020. It's been complemented with the time use survey and the health survey for England. The second is the quant project. So we've taken it as is. If you have questions about how it's modeled, Mike is here and probably other people from that work stream, so you can ask them directly. Other data for committing, we've created also a synthetic population of business units. That's at LSOA level. It's done by merging 2 data sets are available from NOMUS. It can then be matched to the individual population data set. The geographical data comes from ONS for boundaries and OpenStreetMap for building visualizations. It looks quite nice, the building visualization, as you will see shortly. So as part of the complementary data, we provide some Google data sets for some data about mobility reduction to simulate lockdown. This data is not extremely precise and it's also incomplete. So it can be used as a reference, but then again, if you want to study a specific area, then it might be worth trying to find some more specific data. And as mentioned earlier, we also have some initial cases are coming from the ONS infection survey, also from the data that's available, the official data that's available. I can now hand over to Anna, who will talk about the challenges we faced updating the code of the model.
Do I have the remote control now? Let me check.
You do, yeah.
It doesn't move actually. So maybe.
Try again.
No, it doesn't work. Okay, you back. I give back the control to you. Okay.
Okay, I just moved the slide for you.
Yeah. Okay. So as Hadrien mentioned earlier, together with the data, another challenge of scaling up the model to a national level was to dealing with the code, so that the model could be able to run in different areas. So this implied basically an automation of the model. Great. And the first step was to create a robust and adaptable folder structure, which would take into account the different inputs and outputs of the several steps of the models. So yeah, we are showing the final folder structure that we agreed upon. Again, move forward. So once we did that, it was possible to solve the fact that many variables were specifically defined just for the Devon area. So we soft-coded the variables by introducing a separate module in Python, where we have all the constant definitions. Next. And also another thing which was important is like to enable a selective download from a remote repository. In fact, now the model works with by downloading only the data which is needed for the specific study area extent and taking into account the different scales for the different data sources. Next. All the code is available in the GitHub repositories, specifically in the one of the urban analytics for the University of Leeds. And we have our own branch, which is the EcoTwins, which stands for Ecosystems of Digital Twins, which is a project we work on at Hadrien Turing Institute. But if you ever enter into this link, I want to mention that it's still at a temporary, it's a work in progress, basically. So now I'm gonna hand over to Fernando, who is speaking about, showing them about how the model is working now.
Thank you, Anna. Should I have control to the presentation? Let me see. It seems, yes. Okay, so I'm gonna show you a brief demonstration about the progress that we made in this at national level of the model. So as Hadrien and Anna has mentioned, we have been working in creating a scalable solution for the data, trying to implement or scale different areas inside the UK, and also different activities. We are particularly interested in events. So we wanted to make the model more realistic. So we wanted to include different activities like conference, stadium, events, nightclubs. Actually, one of the use case that we have, we wanted to present in this brief demo is the inclusion of the nightclubs as part of the activity inside the model. As you can assume, once we have a new event, so we have to compute different flows, different population, or estimate different populations, and try to also compute different places for the new areas. So, okay, so here we have a brief video about, let's see if it's loading. So we did a video where we have basically the different scenarios that we want to show you. So I'm gonna play here a little bit. Let me pause here just for a second. So in the video, we are gonna show you how the model is deploying a dashboard that the user can see and how it was deployed for the initial use case using the Devon area. And then we are gonna show you what happens if we add a new activity, then what happens if we work with a different area in the UK, and finally a scenario when we have a combined where different areas or a sample of different area and a new activity. So here we have how the model was running at the beginning with the use case. So the user was able to modify the activity multipliers, the hazard multipliers for home, retail, primary school, secondary school, and work. And what you can see at the left is the estimated for the response of the estimated populations, how many of those were exposed, pre-symptomatic, symptomatic, and especially the number of deaths that we are estimating once we are running the model for this particular area. So in this case, we have 480 deaths in this scenario. And now we also work in adding a new activity. So we are taking the same area, but adding a new parameter. So you can see that we have nightclouds as the parameters. I'm gonna pause here because it's kind of fast. So we see that we have a new parameter, nightclouds, as part of our estimation. And once we run the model, we assume that the model has to respond for the new parameters. And you can see this little, it's kind of fast, but this little red dots shows how the disease is spreading around the area. And it's basically responding for the new parameter. So we can see that now we have almost double of the deaths because of the new parameters that we have. So this is something that we need to test continuously to check if the new activity is supporting what the model is supposed to do. So now what happens if we have a new area? So we also work with West Yorkshire. So what you see in the video is this area. So we need to compute the flows on the population for this area. And once we run the model, also we can see how the disease is spreading around the new area. And at the left, we got the new outcomes about the models responding for the new area. So finally, one of the things that we also need to test, as you can see now, we have different outcomes in terms of deaths. And now what we've been working is to have the combination of the two updates, a new area and with new activities. What you see here is a 10%, it's a sample of 10% of the West Yorkshire area. And also we have included the new activities like nightclubs. And once the user is able to run the model, we can see the new outcomes or how the model is responding for the new area or the different area and the different activities. So hopefully we are gonna support more areas and include more activities as different kind of the events. So I hope this video can help you to understand what is the outcomes and or the functionalities that the dashboard has. And I'm now gonna hand over to Man, who is going to present the features and possible collaborations that we are looking for in this contribution.
Okay, thanks, Fernando. Now I'm going to talk about the future directions. First, let's look at the model's performance and the limitation. The first limitation is that the initialization can be very slow. It takes about 2 hours per 100 MSOA, but analysis can be run instantaneously. And the second one is that the MSOA is the minimum practical scale. Both limitations are because of the nature of the data and the performance reasons. For example, there are about 7,000 MSOAs in England. And for the modularity, any missing interactions can be added. For example, can easily refine household transmission at the places of court. And it is the best to run an area of the size of country because the model assumes non-provided MSOAs are entirely empty, and such an area would capture well the different scales of interaction while keeping performance reasonable. Next, please. For the future developments, we can add more detailed individual timetables and consider the transport system morphology. And we can also make an improvement for the calibration and the testing phase. Next. There are also some possible case studies and collaborations. The first one is about the model generalization ability. We can try different urban settings and COVID variants, or we can develop potent social interaction model besides epidemics, such as the low carbon features. The second one is about health and economy. We can search for a policy based on current model, which can simultaneously minimize the infection spread while maximizing economy preservation. And the last one is about the recovery strategies. We may be able to also search for the recovery strategies based on the current model so that people can return to normal life while minimizing infection spread. And thank you for your attention, and we're happy to take questions.
Super, thank you all. I'll do the same as we did last time. We've still got a few minutes, so we'll do 1 or 2 questions now and then come back later for more. Reminder, you can ask questions at any time using the Q&A functionality at the bottom. So, Hadrien, I wondered whether you could just say a little bit more about the difficulties and importance of establishing the number of active COVID cases at the start of the model.
Well, usually, so in the previous model, I mean, we've been going back and forth on the seeding thing. So the current idea is to have the user specify what they want. So if you want a realistic scenario, then you would use realistic data. And the issue is whether we should use the number of new cases, for example, or the number of active cases. And in a sense, the number of active cases are more important to us because that's people that might be contagious. So that's the best way of seeding the model. Right, so we have some data, but it's not, I mean, it's projected from the national level onto MSOAs. So that will still be some work to be done in case you want to have a specific case study.
Okay. And on the Google mobility data that you use, on the face of it, these data have excellent temporal resolution, but the spatial resolution is a bit coarse in relation to the rest of the model. Is that right? And where might you look for better data?
Yeah, so the spatial resolution is county level. That's the smaller county, so it's 82 for England. So it's not that bad, but I mean it's not absolutely great. And also the issue is some of them are missing, and it's not always the same depending on. I mean the data that's missing evolves throughout the period. So what we've done is we've all the missing places we've just set them to the national average. That's not the best way of doing it. but that is quite an issue. I mean, where you would find better data, I'm not really sure. Also, the thing is, this data is about, it's the global reduction of mobility. So we're assuming that all activities have been reduced equally, which is probably not the case.